Hey, scholars. So I want to talk to you quickly about some really cool equivalent ratios. So if you would, just give me a second to share my screen with you and we can get started. Cool. So we'll start like we normally do with our affirmation. So repeat after me. I am an awesome, brilliant child, determined eternally for greatness, helpful, intelligent, joyful, kind, loving, mindful, and naturally outstanding. Phenomenal, questioning, respectable, smart, talented, unique, and virtuous, wise. Exciting, youthful, and zealous, and then some. Great job. So now we're going to choose our norm for the day. So remember, your norm for the day is how would you like to think for the day? Would you like to be well dressed, well organized, well balanced, well read, well spoken, or well traveled? Awesome. So you've had some time to think about it. I'm sure you picked an amazing well. So equivalent ratios. How can you create and compare ratios? I can make tables of equivalent ratios relating quantities with whole number measurements, find missing values in the tables and plot the pairs of values of the coordinate plane, use tables to compare ratios. So how many scholars will we have? If seventh grade has the same amount of scholars in sixth grade, how many scholars are in seventh and sixth? So if one class has 24, one has 25 and 23, and they're just doubled in seventh grade, how many do we have in all? Think about it. So we also have math gap. The ratio is the quantitative relationship between two amounts showing the number of times one value contains or is contained within the other. Equivalent. Equal in value, amount, function, or meaning. Some notes. So equivalent ratios, they're really good to look at. So if you see, we have ratios where one number is to another number. So for every one, there's 5. For every 2, there's 10. 3, there's 15. And 4, there's 20. These are all equivalent. This table really helps us figure that out. So for every one boy, there are 5 girls. That means for every 2 boys, there'll be 10 girls. 3 boys, 15. 4 boys, 20 girls. It seems as if every time this number was manipulated or changed, so did this number. So we know, kind of with fractions, whatever you do to one side, you have to do to the other. So when the boys double from 1 to 2, the numbers double from 5 to 10. Likewise, when it tripled from 1 to 3, 5 did triple to 15. And then we have a number line here to explain the same. So, equivalent ratios, two ratios that are equivalent or equal, the value will stay the same, but the numbers will be different. So again, we have the same kind of example. We have 1 to 5 is equivalent to 2 to 10. Why? Because if we think about our lowest common, that's right, multiple, at least common multiple that two numbers have in common, it will be 1 and 5 here. So what number is transitioning 1 and 5 to 2 and 10? 2. 1 times 2 is 10, 1 times 2 is 2, 5 times 2 is 10. So for every 1, there were 5, and for every 2, there are 10. Again, the same concept is here, 2 to 4. How is 2 to 4 equal to 8 to 16? Well, the lowest common factor of 8 and 16 are, or rather the greatest common factor of 8 to 16 is 4. So 4 goes into 8 twice and 4 goes into 16 4 times. And so here we have 2 to 4 is equal to 8 to 16. So we're noticing the equivalent ratios are the lowest common factor of ratios compared to greatest common factor, right? So 4 times 3 is 12, 7 times 3 is 21. This is how 4 over 7 is equivalent to 12 over 21. If I multiply these numbers, the concept here is multiplying and dividing. Whatever you do to the top, you must do to the bottom. So let's try it. Here's a quick example. We see there's a relationship between 18 and 6, but there's a blank one here. Okay, so I know that 18 is a multiple of 6. What times 6 gets me 18? 3. 3 times 6 is 18. And so whatever I do to one part, I need to do to the other. So 18 divided by 3 gets me 6. So 15 divided by, right, 3 will get me what? That's right, 5. So let's look at this relationship. We have 5 over 6 equals 10 over blank. We can use the same concept. So 5 is a factor of 10. We can change 5 to 10 by doubling it. 5 times 2 equals 10. So what do we do to the bottom? That's right. The same thing, multiply 6 by 2. So 5 times 2 is 10, and 6 times 2 is 12. That's right. Now, here's where it looks really confusing, and sometimes it tricks us up. If I'm looking at this, 10 over 12, and then this, it doesn't seem like they have a relationship. But we have to remember that the lowest common factor here is the same. So we just have to go back. So how do we go from 6 to 30 instead of 12 to 30? Well, 6 times 5 is 30. I knew that because I know my 5 times tables. 6 times 5 is 30. So what do I do to the top? The same thing. 5 times 5 is 25, as I'm sure some of you saw. So we have the same thing. These are equivalent fractions. Here, 5 over 6 is our lowest. But as we manipulate it on either side, we see 5 times 3 gets us 15, means 6 times 3 gets us 18. 5 times 2 gets us 10, like 6 times 2 gets us 12. 5 times 5 gets us 25, as 6 times 5 gets us 30. So here's a real world example for boys to girls. We kind of looked at this earlier. Ratio of boys to girls. For every 3 boys, there are 5 girls, or 3 over 5. We can see this is also manipulated the same way, just kind of how we just reviewed. We're going to multiply this by 2 and get 6 over 10. And then we multiply it again and get 9 over 15 and 12 over 20. Do you see how they just multiply the top and bottom by the same number? So in order for us to get equivalent ratios, multiply the top and bottom or both numbers by the same number. Remember, it's going to change the number, not the value. All right, so here's some quick connections we can make, and then I will let you go. Can you see any matches between these equivalent ratios? I see 1 and 5, or rather 1 to 5 and 2 to 10. With remembering what we just learned, 1 times 2 gets me 2, and I know 5 times 2 gets me 10. So these are a match. Is there anything else? I see 1 too. So if we can look at this ratio 4 to 7, I know there's a relationship between 4 and 12 because 3 times 4 gets me 12. Ooh, and 3 times 7 gets me 21. So they must be correlated. Are there any others? I also see 5 to 6. I know a multiple of 5 is 25. So 5 times 5 gives me 25. Likewise, so does 6 times 5 get me 30. So you can take some time and practice with a few more and see if you see any more correlations. Remember, you're making a table to find the equivalent ratio. Thank you so much, scholars. I look forward to seeing you soon. Love you guys.